I want to talk to you about Eliud Kipchoge. Eliud Kipchoge just took 78 seconds off the men's marathon world record. An amazing achievement, and one that will certainly potentially stand the test of time. Now, previous gains had been a few seconds here and there. In fact, Eliud did this despite his pace runners falling by the wayside early on. An amazing achievement and a marvel of dedication and commitment and the hard work that goes into it. Or it wasn't because he worked hard. It wasn't because he's committed. Did Eliud run the fastest marathon because broadband speeds are getting faster? Is the internet the reason that he broke the record? Let's take a look. Marathon record times have been doing this over time. As internet speed has increased, marathon record times have decreased. So clearly, despite spending 15 years training, committing, balancing his diet, doing the hard slog at the night, in the rain, in the wind, altitude training, having elite coaches, using pace runners, actually, the fact that companies like BT have sped up broadband is the real reason for the record. Or is this more nonsense? Well, it is nonsense. But this goes into a fundamental idea that is so prevalent today. And it's the battle between correlation and causation. Now, I'm going to try and avoid controversial topics in this. A classic case, though, which we're not going to discuss, is immigration into the United Kingdom and the effect of it. But it is a really, really difficult issue. Correlation and causation. So, what do these two things mean? A correlation occurs when, as one thing increases, another either increases or decreases. So, here is two examples of correlation. A positive correlation and a negative correlation. Here is a positive correlation. And here is a negative correlation. Positive means as this goes up and increases, this also increases. Now, we've already seen an example of this in part 10. As ice cream sales increases, drownings increase. Here's an example of negative correlation. As this increases, this decreases. Now, this situation is exactly what Eliud faced. As the speed of the internet increases, marathon times decreased. And I could draw a line to show the trend on both of those. Now, both of these relationships, positive and negative correlation, are really important. And the big question you have to ask is why? What is going on? The answer is sometimes nothing. Causation is very different. And causation is often what people assume is happening. So, as the number of people on the population of the Earth increases, the amount of CO2 produced by humans increases. Now this makes complete sense. The same will be true for the example we looked at previously, where we looked at the weight and height of people. In fact, in this case, as height increases, weight tends to increase. Now, I said tends to because it doesn't always. But these relationships have a cause. The population increases, so people eat more food, there's more industrial activity, more factories are built, more homes are built, more cars are used, and therefore CO2 used increases. There is a direct causal relationship. This increasing makes this happen. Height and weight is the same. But what about Eliud? Is this a causal relationship? No. This is a correlation. Now, with a correlation, there may be a hidden factor causing it. So in this case, you might say, perhaps the hidden factor is technology, both in terms of his shoes he wears, his training methods, and of course those will have the similar effect on internet speed. You can develop technology to improve that. Causation is where the factor is clear and on the diagram. So two things can appear linked, but actually the factor is hidden. Let's go back and work out the hidden factor in ice cream sales and drownings. The hidden factor that causes both of these things to increase. I didn't do art GCSE. Summer, sunshine, the temperature increasing. There are the hidden causal factors. So the two variables had a correlation, but the hidden factor was temperature. In a causation situation, it's very clear what is happening. So here you can describe how the population causes more CO2. But here you need to describe something else changing both of these things. Now, people will get these two wrong all the time. And as you can see, in some cases it can lead you to draw dramatic conclusions like banning ice cream. But what you need to discover is what the root of the issue actually is. And I think in modern life, there are some big questions we need to ask about what's really causing the changes. So, always look carefully. Looking at scatter graphs and finding relationships, like a positive correlation where they increase together, or a negative where one increases and one doesn't, are vital. But what you mustn't do is mistake a correlation for a causation. Now, a few quick notes on correlation before we move on. If I draw this really well, you're going to see a positive, perfect correlation. Can you see any outliers here? No. This one is a positive, strong correlation. They are fairly tightly packed. Here, there is some kind of correlation. We'd say this one is a weak positive correlation. Three key words you need to be aware of. And then the last one. The hours I sleep a night and goals by Liverpool that weekend. Do you think these two things have any link at all? Well, here's what you get when you chart these two variables. Does it go clearly up? Does it go clearly down? No, it doesn't. There is no correlation. So, you don't have to worry about hidden factors causing a relationship. There simply isn't anything going on. So no matter how much I try and sleep more in order to score Liverpool more goals, it doesn't work. In the next part, we're going to look at plotting a scatter graph, and then we're going to look at how you can start to use them to do some very basic calculations.